it's pretty easy for us to look at a plant and say, that's a happy plant, that's healthy, it's doing fine, or this one's struggling. And the charcoal really seems to make plants happy. They just are more adaptable, they're just solid.
Charcoal that is intended to be applied to soil is often called biochar. And biochar applications to soil can have a number of positive effects. Charcoal can increase the water holding capacity of soil. It can increase cation exchange capacity. In the process, increases nutrient retention in surface soils. It can stimulate microbial activity. It can absorb organic matter and create sort of a seed for humic material formation in the soil environment. It is black in color, so it tends to have a positive effect on the albedo effect of soil, allowing it to warm more rapidly in summertime or springtime.
Biochar feels like a really exciting solution because it hits a lot of problems with one action.
When we applied biochar to the surface soils, that it greatly reduced the net leaching of nitrogen and phosphorus.
This year we found significantly higher levels of plant-available phosphorus in biochar-treated plots. And phosphorus is pretty important in the soil ecosystem and its benefit for plants because it involves in the chemical reactions in the photosynthesis process.
The charcoal has the potential to increase the resilience of soil to drought conditions. It has been shown to increase surface water holding capacity in some instances.
If our crops can thrive on 10 to 25% less water, that's pretty huge. And if you spread that out over a state or California, I mean, holy cow, that's a lot of water.
So this year we found that microbial biomass carbon increased 40% in biochar-treated plots. And also we tested a couple of microbial indicators, including in enzymes activities, and we also found an increase in enzyme activities, indicating active soil microbial community.
Carbon is really important for the life of the soil. Carbon is the currency of energy in the soil environment. Charcoal is generated by heating under low oxygen conditions. It yields a very recalcitrant, carbon-rich material that is also very good at absorbing organic carbon in the soil environment. It's an indirect effect of the carbon on the quality of the food. Having a soil that's rich in organic matter, that has high pools of metabolic organic matter, drives that microbial activity that frees these mineral nutrients from the parent material or the geologic strata, and you have greater uptake associated with it of all different micronutrients and macronutrients.
Nutrients needs to be processed by microbes to be available to roots in a similar way that food needs to be processed by our intestinal flora and made available to our bodies.
A healthy soil produces a healthy crop, which is consumed and produces healthy people.
My mom is a nurse practitioner, and so she's looked at a lot of people, and a lot of sick people, and a lot of healthy people, and she always says, you guys look so healthy. And I think it's because of our lifestyle, but also a lot because of the food we eat.
So we looked at micronutrient density in the dry beans that we harvested from the plots receiving the biochar and no biochar, and we found higher micronutrient concentrations in the dry beans that had received the biochar applications versus those that didn't.
The nutrient density in that crop of beans was much higher than in the control plots. So I guess the main thing is that all food isn't created equal.
It has the potential to stick around for hundreds, thousands of years. And that means that it is a form of carbon storage.
If you make charcoal and burn that material in an oxygen-free environment, 40 to 50% of that carbon is stored in the charcoal and then preserved for between hundreds to thousands of years. That is a way to keep carbon where it belongs, down in the soil and out of our atmosphere, where it's creating larger problems with global warming.
I cannot think of any reason not to do it. If you can get your hands on char or make some char, especially here in the Pacific Northwest where we have an abundance of biomass, especially in forests that are becoming overstocked, a fire danger. If if we can turn some of that biomass into charcoal that's going into our food production ground to produce higher quality soils and higher quality foods, I just really cannot conceive of an argument against that.
Charcoal provides a sort of holistic approach to addressing a whole series of issues that face farmers, and if we can provide that in a way that addresses these issues for generations, that stays in soil for not only 5, 10, 20 years, but literally for millennia, this could be a long-term solution to food security as we move forward.